Okay, well, we're going to start the next section. This is going to be section 10.4 that are following home from my class, but if you're not, this is just going to be a tutorial on how to use the sum and difference formulas to solve complex solutions. The sum and difference rules are part of trigonometry and pre-calc that are useful, not always used very much in high-level math, but are useful and can make your life a lot easier if you can notice and know how to apply them correctly. So let's get introducing what are the sum and difference rules. The sum and difference rules are essentially when you have a sine cosine function and you are adding or subtracting two different values together. You can also apply these when you have tangent, which can be written as sine and cosine of the same thing, and then you just write them out in the long form. For this, what we have is when you have sine of theta, you probably want to write these down. And we're going to be applying these in just a little bit. But you want to write these down in your notes. They're easily accessible, usually in the front page of any textbook, but write them down and use them as needed. You can see when you have a sine of a plus, it alternates between sine of an angle, cosine of the second angle, plus cosine of theta or alpha times sine of beta. Cosine of alpha plus beta, two different angles. So just so you know, these are two angles, two different angles. And so we have cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. And then sine of alpha minus beta is sine of alpha, cosine of beta, minus cosine of alpha, sine of beta. And cosine of alpha minus beta, cosine of alpha, cosine of beta, plus sine of beta, sine of beta. All right, so without further ado, let's try it and figure these out. And how do these work? Well, um, you'll see in a lot of my slides, I'll have these written above, okay, just so we can make easy reference to them. So essentially what they're used is to make things easier in order to find sine, cosine, and tangent of angle by hand. For example, 255 is not a common angle. So for example, if we would write, if we want to find the sine of 255, well, literally, we could not do this. We have to put it in our calculator. However, 255 we know can be broken down into two different angles. The two different angles can be broken down into are, well, 300 minus 45. And there are other variations you could also use with this. The key thing is we're going to try to find two angles that can be added or subtracted together that are common angles, that have reference angles of 30, 60, or 45. Well, 300 degrees, I'm just going to draw this right below right here. 300 degrees we know is down here in the fourth quadrant and has a reference angle of 60 degrees. 45 degrees we know is going to be in the first quadrant and has, all right, a common ratio of 1 to 1 equal 2, and we can solve that from there. Well, however you write it, we're now going to look up here and pick which one we'll have. Well, since it's sine, we're going to be writing this now as sine of 300 minus 45. I want to say again, when you're doing this, it doesn't matter what two angles you do. You just want to make sure that they are either 45, 60, a 30-degree angle, or even a 180 or multiple of 90. In this case, we picked these two right there. So you want to get into those multiples. Now from here, what we're going to do is now we're going to use the property of the difference right here. So with that, we're going to take this and we're going to take the sine of 300 minus 45. Well, that is the difference of two angles. This is going to be alpha, and this is beta. So we're going to write the sine of our first angle, so it'll be the sine of 300, times the cosine of beta, which in this case is 45, minus the cosine of alpha, which in this case is 300, times the sine of beta, which is 45 degrees. From here, we can simplify this and take the sine of 30, or 300 that is. Well, over here, we know it's going to be negative square root of 3, 1, and 2. So sine is going to be negative square root of 3 over 2. We know cosine is 1 to the 1 the radical 2 come out now. So we know that's going to be square root of 2 over 2. Minus cosine. Cosine is going to be 1 over 2 for 300 degrees. This is 1 over 2. And sine, once again, of 45 is going to be the same as cosine of 45, which is square root of 2 over 2. From there, we can multiply, and we can find our new angle is going to be the square root of 6, negative square root of 6 over 4. minus the square root of 2 over 4. And we can simplify it and put those together. But in any case, that would be our solution. That is our answer. Okay? We can do the same thing for another angle. So whenever we can break down any angle, okay, we can do this with any other values as well. We can do this same thing and go into cosine and tangent and so on. So we'll do cosine of the same thing. So if I took cosine of 255, picking this, we would have cosine of 300 minus 45. And right here, cosine of 300 minus 45, we're going to be using the difference of cosine. And so we would have this, once again, cosine of 300 times cosine of 45 plus the sine of 300 times the sine of 45. Going through, we would have cosine of 300. Cosine of 300 degrees is going to be 1/2 square root of 2 over 2 plus sine. It's going to be negative square root of 3 over 2, and then the square root of 2 over 2. That can be simplified to the square root of 2 over 4 minus the square root of 6 over 4 as our answer. The tangent we can write is simply the division of those two because it's sine over cosine. So the tangent of 255 is simply going to be the sine of 255 over the cosine of 255. And so you can just take these two values right there, negative square root of 6 minus square root of 2 over 4 over 2 minus the square root of 6 over 4, which you would realize that, hey, take the reciprocal, the 4's will cancel out, and what you have is negative square root of 6 minus the square root of 2 over 2 minus the square root of 6 as your answer. Okay, so that's one of them. I have another one here, if you want to, and I'm going to take this, and I'm going to actually duplicate this slide really quick. I'm going to pause this. So in doing the next one, we're going to try this one. I made up another sheet for it. And so from here, once again, you can pick out any values you want. So 105. Any multiple of 105 that can be added or subtracted together that have 30, 40, or 45. I picked this right here, 60 plus 45. 60 plus 45. 60 plus 45 equals 105. These can be in any order. It doesn't matter. You'll get the same answer regardless. So if I want to find the sine of 105 degrees by hand, if I know that 60 plus 45 is 105, I could write it as sine of 60 plus 45 degrees, and now use the sum formula of sine, which would be sine of, remember this is alpha, this is beta, so it'd be sine of 60 times cosine of 45 plus the cosine of 60, all right, times the sine of 45. And there we have it. Okay, so just flip-flopping those two values. To find our answer, we would go through and figure out what the sine of 60 degrees is. So once again, 60 degrees right here has a ratio of right equal 3, 1, and 2. And our 45-degree angle right there has a ratio of 1 to the 1 to the right equal 2. Come on now. And so the sine of 60 is going to be square root of 3 over 2, which you know from our circle chart. Cosine is going to be square root of 2 over 2. Cosine is 1/2. And then sine is square root of 2 over 2. Simplifying, square root of 6 plus square root of 2 over 4, and that's our solution. We can also find the cosine of 105 by using the same type of angles. We can take the cosine of 60 plus 45 degrees, and we can use the sum of cosine, which is this right here. So the sum of cosine we know is going to equal, once again, now this is alpha, this is beta. It's going to be cosine of 60, cosine of 45, minus sine of 60, and then sine of 45. Once again, I'm just reading this right here and just copying and pasting. Pretty easy, pretty standard going through here. From this one, cosine of 60 is going to be equal 1/2. Sine is square root of 2 over 2. We got minus sine is going to equal of 60 is square root of 3 over 2. And then we have the square root of 2 over 2 right here. Multiplying through, square root of 2 minus square root of 6 over 4 would be our answer. Okay, then find the tangent. The tangent is simply the of 105 is going to be the sine over cosine. So it's the sine of 105 over the cosine of 105. And we know we can just take this sine divided by the cosine, which if you saw our previous one, can be simply simplified like this. And we'll just leave it as that ratio. You put in the calculator, and that will be the same value if you would put in tangent of 105 and cosine and sine. Okay, so that was the introduction of how to use the sum and difference formulas to write by hand without your calculator how to find angles that are not essentially right off the bat you see them as our primary and basic angles. Okay, so look for my other videos on how to use this sum and difference rule in a few bits.